are going to explore horizontal asymptotes for rational functions in 3-part videos. In this first part, we are going to define what a horizontal asymptote is, what one might look like, and one particular rational function, f of x equals 1 over x, and its horizontal asymptote. Alright, let's first start with the definition. A horizontal line, y equals k, where k is a constant, is a horizontal asymptote for a function f if f of x approaches k as x approaches plus or minus infinity. So let's illustrate that with a particular k. Let's let k equal 3. And let's let x approach positive infinity. Now what might a horizontal asymptote look like? Well, here's going to be our horizontal asymptote, y equals to 3. Our function, f of x, could come up from underneath and approach the line y equals 3 as x gets really large. It could also come down towards the line as x gets really large and approach the line y equals 3. It could also cross the line and approach the line y equals 3 as x gets really large. Well, what about in the other direction? Well, let's still let k equal to 3, and this time let's let x approach negative infinity. Well, if we draw our dotted line to represent our horizontal asymptote, y equals 3, then like as x approached infinity to the right, as we approach it to the left, our function can come up towards that line, y equals 3. It could come down towards that line, or it could cross that line and then come down onto the line. Okay, so these are some visual representations of what a function might look like as it approaches its horizontal asymptote. Alright, let's look at a really particular one. F of x equals 1 over x. Okay, and let's explore what happens as x gets really large and x gets really large negative. Okay, so as x goes towards infinity, let's actually record some of those values and see if we can get a trend. Okay, so when x is 1, we get 1 over 1, which is just 1. When x is 2, we get 1 over 2. When x is 3, 1/3. Let's jump up here. What about when x is 10? It's 1/10. Or what about when x is 1,000? We get 1 over 1,000. Notice as x gets very large, or approaches positive infinity, my f of x goes towards 0. Notice it'll never reach 0, nor will it ever cross 0. Okay, so in this case, we note that y equals 0 is a horizontal asymptote for f of x equals 1 over x. And so what that means, as x gets really large, notice I'm coming down closer and closer to y equals 0. Okay, well what about when x gets large negative? So we're still looking at f of x equals 1 over x, and this time we're going to have x approach negative infinity. So how do things change then? Let's see. Well, what about when x is negative 1? Well, then we have 1 over negative 1, which is negative 1. When x is negative 2, we have negative 1/2. I think we can jump ahead. X is negative 10, it's negative 1/10. Negative 1,000, we get negative 1 over 1,000. And we see this time that as x gets large negative, f of x goes towards 0. But this time, it's coming up towards the line y equals 0 as x goes off towards negative infinity.